Hey there, you already know that for whole numbers and integers, a plus b equals b plus a. And we know this to be the property called as commutative property. This property tells us that even when we switch the places of these numbers, the value remains the same. A plus b equals b plus a. For example, 1 plus 5 equals 5 plus 1, and both of these will be equal to 6. And the same thing happens even if you include negative numbers or integers. Minus 8 plus 3 will be equal to 3 plus minus 8, which is both being equal to minus 5. Switching the places of the numbers does not change the value of the addition. So addition is said to be commutative for whole numbers and integers. But is it the same for the rest of the rational numbers? Let's check it out. Is addition commutative for rational numbers? Let's take one example. Is a plus b equal to b plus a? So we take the example of minus 3 by 4 plus 1 by 2 and see if it is the same as 1 by 2 plus minus 3 by 4. How will we do that? We'll add them up and we'll see the answer. So when you take the LCM, you get 4 is the LCM, so 2 times 2, and you here have 1 times 2. So that would be minus 3 times 1 plus 1 times 2 by 4. And that would be minus 3 plus 2 by 4. That will be minus 1 by 4. And this side, we have the same LCM as 4. And we have 1 times 2 plus minus 3 plus 1 by 4. That would be 2 plus minus 3 by 4, which is minus 1 by 4. And as you can see, we get the same answer on both the sides. And so this addition is the same as this addition. This is just one example. You could take any two such numbers, any two such rational numbers, you could add them up and you will always end up with the same answer regardless of whether you start with the first number or the second number. We cannot prove this is true from just one example, but what scientists have done is they have continued to do this for millions and millions of examples, and they've always found this property to always hold. And that's why we know addition is commutative for rational numbers, for all rational numbers. Is subtraction commutative for rational numbers? Is a minus b equal to b minus a? Let's see with an example. So minus 8 by 5 minus 13 by 10, is it the same as 13 by 10 minus 8 by 5? Let's see. So the LCM here is 10. So this is going to be 5 times 2. And this would be minus 8 times 2. And that would make it minus 8 times 2 minus 13 times 1 by 10. That will be minus 16 minus 13 by 10. And that will be minus 29 by 10. And let's see this side. The LCM is 10 again. And this would be 5 times 2 and minus 8 times 2. And that is going to give you 13 times 1 minus 8 times 2 by 10. That would be 13 minus 16 by 10. That would be 13 plus 16 by 10, and which will be plus 29 by 10. The exact opposite answer. So these two are not the same. So this means subtraction is not commutative for rational numbers. And note that even one single example to show that it is not commutative means that for the entire list of rational numbers, even if some of them happen to be commutative, even if you can find one example, one exception is enough to show that subtraction is completely not applicable for commutative property of rational numbers. One exception is sufficient. Let's see if multiplication is commutative. Is a times b equal to b times a? We check with an example. 7 by 2 times minus 2 by 5. Minus 2 by 5 times 7 by 2. That would be 2 into 5 is 10. 7 into minus 2 is minus 14. So that will be minus 14 by 10. Simplifying would be minus 7 by 5. So let's see here. 5 times 2 minus 2 into 7 minus 14 by 10 equals minus 7 by 5. That's clearly the same. So yes, multiplication is commutative for rational numbers. And as we saw earlier, we can continue to find different examples and multiply, and we'll always end up with the same answer. Always end up with the same answer for all rational numbers. Let's see for division. Is division commutative for rational numbers? Is a by b equal to b by a? Let's see with this example. Minus 16 by 9 divided by 8 by 3. Or 8 by 3 divided by minus 16 by 9. So as you know, division can be converted to multiplication. We can take a reciprocal of this and convert this into a multiplication. So this is going to be minus 16 by 9 times 3 by 8. We could first simplify it. So that will be 8 ones, 8 twos, and 3 ones, and 3 times 3. So that will be minus 2 times 1 by 3 times 1. So that will be minus 2 by 3. Let's see in this side. So 8 by 3 multiplied by, I'm going to take a reciprocal of 9 by minus 16. So similarly, 3 times 1, 3 times 3, 8 times 1, 8 times minus 2. So that will give you 1 by 1 times 3 by minus 2, which is going to be minus 3 by 2. It's clearly not the same. So these two are not the same. So division is not commutative for rational numbers. One exception is sufficient to show that it is not commutative. So for rational numbers, addition is commutative, subtraction is not commutative, multiplication is commutative, and division is not commutative. Hope you had fun learning. See you next time.